Hello, this is chapter 5. We are starting Calc 2, and some of it you have already seen, you must have seen in Calc 1, but I just wanted to start it from the beginning. So, mm, among other problems like the tangent problem and the velocity problem, there are couple of other problems around which calculus was built, or which were the most you know important problems that this these researchers and the mathematicians probed, or they wanted an answer to those. So one of them is area problem and the other is the distance problem. So we will start with the area problem, but before I start, let me explain know what we mean by sigma notation. Now, what is sigma? You might have heard it or seen it in the name of a fraternity or a sorority. They use these Greek alphabets, which are alpha, beta, gamma, delta, eta, and so on. So, sigma is a letter which corresponds to the letter S in our English language, and sigma is a tilted M, like this. This is sigma, uppercase. Now, lowercase sigma looks like this, which is used for other stuff, but this sigma is basically we use it for summation, where we want the bunch of things to be added together. So how will we know that we have to add bunch of things? Well, there will be a variable, so the variable takes on different values, and as it takes on different values, we get new terms, and sigma tells us to keep adding them. Now these variables are called in this sigma notation, the variables that we use are called indices. So one of them is an index, and it takes on integer values only. It could be negative integers, could be positive integer, could be 0. So it takes on integer values only, and the commonly used symbols for the index are k, I, or j. There could be more, but I think these are mostly enough to express your problem. So what do we mean by that? So it's here we have the sigma notation. Look here, I am writing here I is equal to 0, and on the top I have 3. So it means I is going to take on values 0, 1, 2, and 3. That's all. This top tells us the maximum, and the bottom is the minimum. Even if I don't put I, if I just say here 0 to 3, but if I see whatever my index here is, here I am using 2 to the I, but even if I use 2 to the k, it will give me the same result. And if I use 2 to the j and 0 to 3, or can say here k is equal to 0 to 3. So they are all same. It doesn't matter what index you are using, as long as you are using in all the proper places. Now, so this says sigma means summation I is equal to 0 to 3, 2 raised to the power I. So what does that mean? The first value that I is going to take is 0. So we get 2 to the 0. Okay, 2 to the 0. So we first don't write all this. We first write 2 to the 0. Then the next term value I is going to take is 1. So we'll get 2 to the 1. But we are not going to write them like this with spaces in between. Summation, the sign summation is telling us to put a plus sign in between. Then again, because of the summation sign, I will have a plus sign, and now the next value that I has to take is 2. So we get 2 to the 2, and then plus 2 to the 3, and that's it. I'm done with this one. Well, if you want to simplify, go ahead. So we have 2 raised to 0, which is 1, plus 2 to the 1, which is 2, plus 2 to the 2, which is 4, plus 2 to the 3, which is 8. So we end up getting 15 as our answer. So this is what this sigma notation is. Now another example, sigma k cube. K is going from 1 to 5. So note here I made it go from 0 to 3 or 0 to a number, and here I am making it go from k1 to some number. We can start with a negative number as well. It doesn't matter depending on the problem. So now we have k to the third. Now in the first example, the variable was in the power, so the base remained the same or didn't change, the power is changed. Now in this case, the index is in the base and the power is 3. So since k is going from 1 to 5, so it means k is going to take on values 1, 2, 3, 4 and 5. So I write 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube. Will I write plus 6 cube? No. Why? Because this was the maximum value I could take. So if you want, you can simplify and get what the number is. Now let's look at the properties of this sigma notation. So basically these are very similar to the properties of the derivatives or the integrals that you have seen in Calc 1. So what it's saying is that if you have a summation of c times a function of k, so c, for example, ck or ck square or c times, c is a constant, c is a scalar or a constant quantity, non-zero constant we say, because if we have take a 0, then everything is 0, so we are not able to do anything. So we say let c be a non-zero constant. Then if we have this situation, then we can pull the c out of the sigma notation. Now remember, anything which doesn't have to do anything with the index can be pulled out. Now if you recall, with the derivatives we had a similar property which said d by dx of c times f of x will be equal to c times d by dx of f of x. So see, this is similar property. We say we call this type of property scalar multiplication. Second property is that you have sum of two functions of k, and you want to take the summation on from whatever index value, then you can actually split it. So again, this is similar to the derivative property. So if you are taking the derivative of a sum, it becomes the sum of the derivatives. In this case, we are taking the summation of the sum, so it becomes sum of the summations. And same happens with the negative sign or a difference. So this is addition, this is subtraction, or we can call this is sum, this is difference. Now note here that there is no product or quotient property. Okay. Now with the derivatives, remember we had a product rule. With the integrals, we don't have a product rule. I mean, it's called integration by parts. When we have a product, there is two things you can do. You will learn in few days that one thing you can do is make a substitution. The other thing you can do is integration by parts. So no specific rule for multiplication, and division is completely a new thing. So similarly we don't have a property for the or a rule for the product of functions. We don't have a summation rule, and similarly we don't have a summation rule for quotient. So, for example, let's see how we will evaluate these some expressions. So note here I told you that the index could be j or could be k or could be uh, the I. So what will happen here? What are the values that j is taking? It's going from 1 to 3. So now I have two terms here. So I can use my distributive property number 2. I can write it as summation j is equal to 1 to 3, 3j plus summation j is equal to 1 to 3 j over j plus 1. And now I can apply the um, plug in the values. But also note here we could have done this in one step, so I don't want to do another one. But this 3 was a constant, so this 3 can be pulled out. Even if you left it inside, it won't be a problem as long as you do not forget it. Okay. So this is equal to 3 times this. Now I will plug in the values for the j. So the first value that j is taking is I, is 1. So we are going from 1 to 3. So what do you think? I'll let you start and then we will see. So because 3 is going to be multiplied with with the sum, so I will put it in brackets like this 3 times. So summation of j, so it means it's just the value that j will take. So 1 plus 2 plus 3 plus, now we don't need to put a parentheses or a bracket on the right of the plus sign I wrote, but if you put the bracket it's not going to be wrong. Plus, now let me put the bracket, so I get 1 over 2 plus 2 over 3 plus 3 over 4. How? Well, the expression is j over j plus 1. So where j is 1, my expression becomes 1 over 1 plus 1, which is 1 half, plus j is 2, then we get j 2 over 2 plus 1, which is 3. So 2 over 3 plus 3 over 4. So that's it. That's what it is. And now if you want, you can simplify it. So this can be simplified as 3 times 6, which is 18, plus, now here I can take the common denominator to be 12, which will give me 6 plus 4 plus 12. No, plus 9, sorry. So 6 plus 4 is, well, this is 19 over 12. So 18 plus 19 over 12. I go ahead. And if you want, you can further distribute and combine the terms. Two 1/6 plus 19 whole divided by 12. And then you add 19 to it, 5 and 3, 235. Okay. Next exam, I hope you guys got it. can understand what I did and how I simplified the expression over here. Now you can use calculator, but do not convert things into decimals. Keep it in fractions. And mixed fraction is not the mixed fraction. Improper fraction is okay. Remember, improper fraction is the one in which the numerator is bigger than the denominator. So do not convert to mixed fraction. Next example. So summation k goes from 0 to 5 x cube minus x square k. So again we can distribute the summation sign. Now note here, this is x cube. I just showed you an example over here where I had a k cubed. So k is the one which is changing. Remember, x is not the one which is changing in this case. So here this x cube can be pulled out of the in front of the summation. We are left x cube. So what is left here? Nothing, right? But nothing is sometimes 0, nothing is sometimes 1. In this case it will be 1. Why? Because I can write it as x cube times 1. So x cube is out, so I am left with 1 here. K is going from 0 to 5 and then minus. Now can I pull something here out in front of the summation sign? Yes. Okay, which one will it be, x square or k? Well, we look at the index is k, so k cannot be pulled out of the or pulled in front of the summation sign. So it is the x square that will be pulled out. So we have x square times summation k. And k is going from 0 to 5. So now we plug in values. So I get, in the first case, let me write it with a different color, or this one will give me x cube, and then I will put this bracket here. Maybe I'll keep the x cube as blue. Okay, so I have 1, right? 1. So what will it give us, or how will you do this? Well, previously we had a the index. Now I don't have any index, so how will it work? Well, if it is 1, what does that mean? It means the function is a constant function. It is f of x is equal to 1. So it's a constant function. So whatever the value of the index, the value that you get is 1. So we say is equal to x cube times, when a k is 0, we have 1, plus k is 1, we have 1, plus k is 2, we have 1, plus k is 3, we have 1, plus k is 4, we have 1, plus k is 5, we have 1. So how many ones I have? 1, 2, 3, 4, 5, 6 ones. And which makes sense, because from 0 to 5, if you count, including 0 and 5, these are 6 digits or 6 single numbers. Okay, so this is first part done. Now the second part. So plus x square times there was a minus, wasn't it? Yeah, minus. This sign was a minus sign. Okay, so now what do I have? Now I have summation k. So it means I have 0 plus 1 plus 2 plus 3 plus 4 plus 5. Again, note here, these are also 6 values, 6 terms. So what does this give me? This first one I get 5x cubed and then minus, this is giving me 5 plus 5, 15 x squared. That's what we get. Okay, the last one, I think you guys should be able to do it. I'll leave you to do it. Just stop the video here. Maybe you can concentrate on the trying to do the problem. Okay, I hope you guys were able to do it. So how would you do it? The same way we did the previous one. Split it in two pieces. So you get summation. Summation I is equal to negative 1 to 2 I squared plus 1. Can be written as summation. Well, I could do it in this step. This is what we have. So I can say now plus summation I is equal to negative 1 to 2, 1. So say we got the similar thing that we had previously. So now, first one, when I is negative 1, I square is 1. Or if you want to do this step first, it's your choice. Plus the next value I is going to take is 0. So 0 square plus 1 square plus 2 square. Plus, so here we have summation of 1. So and I goes from negative 1 to 2, which means 4 values, 4 terms or 4 digits. So I get negative 1. Then will I get negative 1 plus 0 plus 1 plus 2 here? Will I get that? No. Why? Because we don't have a k here. If we had a k here, oh sorry, I here inside here, if we had an I, then it would be negative 1 plus 0 plus 1 and then plus 2. But in this case, we have 1, not k or I. So this will give me 1 plus 1 plus 1 plus 1 for the 4 values that I has to take. So then simplify. So 1 plus 1 plus 4. 4, 5, 6. And then I'm getting 4 from there. So answer is 10. So this is how we do the summation notation. So how is it going to help us? Well, you will see we are not actually doing the whole, all the topics that are given in this section, but still we will see the summation sign later on. Now there are some formulas which are pretty nice, neat formulas, and we are not going to prove them. They are out of the scope of this class, but they are pretty nice. They can make things very complicated things simple. And these are some for on the summation. So this is something we have already seen, the first one, a glimpse of it. So here we are, in each case, index is going from 1 to n. So the first one is saying if you have summation of 1 and k or I or whatever your index is going from 1 to n, then for each value of the index, my function is value is 1. So we will get write 1 how many times? N times. So 1 plus 1 plus 1 plus 1 so on n times will be equal to n. So summation of 1 k is equal to 1 to n will be n. Now if you have summation k I is equal to 1 to let's say k, instead of n I put k, then what will happen? And 1 here inside, if you have summation of 1, where I goes from 1 to k, will be equal to k. So do you understand? The whatever, if you have your function is 1 and your index is starting at 1 and ending at something, then your answer will be that top thing. So for example, if you have k is equal to 1 to 10, 1, then answer will be 10. Okay. Okay. Another thing that you should note is that if you have summation c and k goes from 1 to n, then this will become, remember I can write it as c times k is equal to 1 to n and 1. Now this summation is equal to n and c is just tags along, so we get cn. So if you have a summation of a constant, you will get the constant multiplied by the last highest value that the index is going to take. Okay, the other second formula is that if you have summation k, which you know is something like this, 1 plus 2 plus 3 plus 4 plus 5 plus so on, so on, so on, up to n. If we can total all of them, we always get something like this, n times n plus 1 over 2. Okay? You can try, for example, if you do 1 plus 2 plus 3 plus 4 plus 5 plus 6, let's say plus 7. Okay? So if you want to see what will be this sum, according to this rule, my n is 7, so I will say is equal to 7 into 7 plus 1 over 2, which means 7 into 8 over 2, but 2 cancels this, so we get 28. Now let's actually count and see what do we get. 28. So these two give me 5, these two give me 5, and this gives me 5. So I have 5, 5 and 5, so 15, and then plus 6 plus 7, 6 plus 7 is 13, so it gives me 28. Okay, and the next one is summation of k squared, and again k is going from 1 to n. So we get 1 square plus 2 square plus 3 square plus da 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 plus n square. This converts it into this formula with the 3 terms on the top, or 3 factors on the top, not terms. Now these are something you won't need them because we are not doing we are skipping that portion of this section in which these formulas are used. Literally this concept, or this part of the formulas, but but this part should be understandable to you. Okay, so now the last one is summation k cube. Now this is not the last one as a last one, it's last one for us to see. Now of course people have tried finding out what is the summation k to the 4, k to the 5 and so on, and the formulas could be bigger and uglier, so we just stick with these three or four nice formulas. Okay, so this one cube one is actually the same as the k, but we have a square on top, so it is square of the quantity which we get in when we have summation k. See there, n plus 1 over 2, which is the same thing over here in the first in this formula. So but here we square. Okay, So let's look at this one example. It says evaluate this quantity where k is going from 1 to 10. Now what is this quantity? Is this your function of k is equal to k times k plus 1? Can we keep it like this and use apply the summation somehow? Well, if you plug in numbers, it will become complicated. I mean, if you say, okay, 1 and the 1 plus 1, 1 into 2. So this will give me 1 into 2. You could do that, but there is another way to expand this as well or evaluate it as well. Plus, the next value k is going to take is 2. So it will give you 2 times 3 plus the next value k is going to take is 3. So we get 3 times 4 plus 4 times 5. But can you see this is so long? It is going to take a lot of work here because we have to go up to 10. So well, you can try it at home maybe. But let's look at it in some other ways. Can you guys think what we can do? What are we allowed to do? Can we do this? Can I distribute the summation over the product? No, I cannot do that. So that is forbidden. Okay. And so what else can we do? If maybe someone I could hear, we will factor or not factor out, so distribute. So k times k plus 1 can be written as summation k is equal to 1 to 10 k squared plus k. Okay. And now I will apply the property. Even if I don't put the brackets here, parentheses or brackets, the summation is on the whole thing. So we can write it as k squared plus summation k is equal to 1 to 10 k. Now what we do? Well, again, you can just plug in and distribute, find out what is 1 square plus 2 square plus 3 square up to 10 square, and then do this and add up things and get your answer. But also we could use these formulas. So if I have k is equal to 1 to 10 k squared, so it means I have my n is k and n is 10, so I can plug it in this formula. So I get 10 into 11 or 10 into 10 plus 1, maybe keep it like that for now, 10 plus 1 times 2 into 10 plus 1 whole divided by 6, and then plus summation k is just n into n plus 1. Our n is 10, so 10 into 10 plus 1 over 2. Okay, so this will give me 10 into 11 into 21 over 6 plus, well, you see 2 goes into 10 5 times, so I get 5 into 11, so 55. This side expression can be simplified here. So this expression, 2 goes into 6 3 times and 2 goes into 10 5 times and 3 goes into 21 7 times. So I am left with 3 into 7, 5 into 7 into 11 over 3. No, nothing at the bottom. Bottom is 1. So I have 5 into 11, which is 55, times 7 plus 55. This is what is left with me. but I can now actually do 55 times 7 plus 1, which means 55 times 8, which will give me 8 5s are 40, 8 5s are 4440. Now you guys, I don't know if you are clear about what I did here. The see, we have three factors being multiplied on the top. So we have 10, we have 11, and we have 21. And at the bottom I have 6. 6 doesn't go in any of these three. But I see a even number on the top, which is the 10, and I see an even number at the bottom. Since the numbers in the top are all being multiplied, so we can do this. We can do the cancellation, simplification of the fractions right here. So what I will do is, I will cancel out the 6. What am I going to divide it with? Because I just said even on the top, even at the bottom. So what can we divide by an even number? By 2, always. So let's divide by 2. When I divide 6 by 2, I get 3. When I divide 5 by 2, I get, for 10 by 2, sorry, I get 5. Okay. So is that it? Because if we have nothing left in the denominator, then can you see it will be easy to add things up. But if you want to multiply these first and then figure out if there is a common factor, that is going to be a lot of work. So learn this quick trick. Okay, so now we have a 3 here. I think I need to use another color. This is not visible. So we had a 3 here and a 5 here. So we don't have the 10, we don't have the 6. So right now I have 5 into 11 into 21 over 3. But wait a minute, 21 is divisible by 3. So that's what I'm going to do now. I'll take the 3 divided by 3, I get 1. Divide this by 3, I get 7. So what do I have on the top? 5 into 11 into 7. And at the bottom I have 1. Okay. So this will give me, again I could multiply it out. 7 into 11 is 77. Then multiplied by 5, whatever I get, I get. Or I could do 55 into 7, and I don't need to put the 1 at the bottom. So 55 into 7. Now, since we have only two numbers left, it's better to put them in brackets so that this point doesn't look like a decimal. Okay? So over here I didn't use, although I could have used brackets over here as well. But now I really need them. So at least, if not the first one, second one must be put in brackets. Okay, so now we had to add the 55 from the other term here. So we ended up getting 55 into 7 plus 55. So what I did here is I pulled out the 55. So I'm left with 7 here, and I'm left with 1 from this second term. So I get 7 plus 1, which is 8. So now I have 55 into 8, and it's easier to multiply. 8 5s are 40. So we put 0 and carry out the 4, and then 8 times 5 is again 40 plus 4, 44. So 440, 440. That is your answer. Okay. Isn't it neat? Nice, different some kind of math. Okay, so now we come back to our area problem. Okay, as I mentioned earlier, there are among other few other problems that kind of created calculus. One of them was the area problem. So if we have a nice smooth geometrical figure which we are familiar with, like a square, a rectangle, polygon is a symmetric or regular polygon, or if we have a triangle, I think I mentioned uh, trapezium. Trapezium. In all these cases, we have formulas which we can use to find the area of these objects or of these shapes. But if we get something like this, we have here S, this area, this shaded area. We have no formula with us to find this area. Not yet. Okay, so what do we do? Well, so first thing, what do we call it? This is called the area under the curve. Okay, so the question would be, find the area under the curve y is equal to f of x from A to B. By under the curve means automatically it is understandable, it is to be understood that it is means area under the curve and above the x-axis. So we are in the positive direction. So in other words, we could also word the problem as find the area of the region S bounded above by the curve y is equal to f of x, below by the x-axis, and on the sides by the equations or the lines x is equal to a and x is equal to b. Remember, these are the equations of vertical lines. So that's our goal. That's what we need to do. We need to find out this area. So what we do is we start. The good thing is that you guys learned limits in calculus. So that is what we are going to do. We are going to cut this or divide this region into bunch of rectangles, lots of rectangles. How? That is where the procedure comes in. So what we do is, the first thing we do is we divide our interval AB into, let's say, n subintervals. What is n? We could do it 5 in subintervals or 4 subintervals, and then we say, oh no, this is not a good estimate, because remember, it will always give you an estimate. Then we divide it in rectangles. We will add up the areas of the rectangles and we'll say, oh, this is the area of the under the curve. But that will not be the exact area, because we would have lost some some region, or we would have added extra region in our sum. So which means that we are not going to get the exact value. So the value we'll get be an estimate. So how do we divide something into unequal parts? So for example, how if you have a loaf of bread, if you put one cut, doesn't matter where. In our case, we want to be them to be of the same size. So I don't know, maybe you want the bread to be cut into same size pieces. So let's say if you put a cut here, how many pieces we have? 2. So one cut, 2 pieces. If I put another cut, how many pieces? 3. So 2 cuts, 3 pieces. If I put another cut, third cut, so now I have 4 pieces. So can you see, if I put another cut, so 4 cuts, you'll have 5 pieces, and so on. So how can we figure that out? Well, you find out the length if you want them to be equal pieces. So we will divide we will divide our interval AB. So this is A, this is B, into n subintervals. So if I want to do it with, for example, three subintervals, how many cut marks I will have? 1 and 2. And how will I find out the, so 2 cuts create three three subintervals. So whatever the length is, I will divide it by the number of cuts, the number of intervals, sorry, which we have to create. So if I want to create 3, I'll say b minus a over 3. So what that give me? That will give me how much the length or the width of this interval would be. Or the other way it goes is, if I know the length I have to take, and I divide the total length of the first interval by the length of these small intervals, then I get how many intervals you will get. So that will tell us, and so vice versa. So this is what we do. We have our figure. We find what will be the width of one rectangle or every rectangle. So we call it delta x, change in x if you recall. So we denoted by delta x the width of the rectangle. And then how do we calculate it? B minus a over n. So when we do this here, see, this is x1, x2, x3. So these are kind of your cuts in the bread, but here we call them tick marks. So we put them all at equal spaces. How many tick marks would there be? N minus 1, because remember, with the bread, these are kind of your tick marks. So this is what we do. And last one is that we put is x sub n minus 1, because the b is already there from the beginning, a is already there from the beginning. So now these subintervals, these are created. Ax1, this one, then x1, x2, then x2, x3, and so on. These are the subintervals that are created. So note here, if we look at the first one, ax1, then you can see that a is the left hand point and x is the right hand point of that interval. If you go to the second interval, now x1 is the left hand point of this interval. Remember, x1 was the right hand point of the previous interval, and so on. So you will see there is some overlap going on. The right hand point of one interval is the left hand point of the next interval. Once we get here, once we start, let's say, so this is A. This is where we are starting, and our interval is going back. If I choose left end point to be my value at which I will take the height of the rectangle, I want my rectangle to be that high, then our first rectangle will be made here like this, and then I will draw, because this will be where I will be. If at A the height is, or the y value, and the y value is the height or the distance of the point from the x-axis. So this is our, so what is, how can I find it? How can I figure that out? Okay, let us come back to it. Let's see. So if I am going to use my left hand points, then can you see this will be the left hand point of the first strip, or whatever you call it. This will be the second left hand point of the second strip. So this will be the height of the second rectangle. In the same way, this will be the height of the third rectangle, and so on. So how do I complete my rectangle? Well, because my left side is my height that I am keeping. So I go this much and then I go that way just to complete the rectangle. So can you see this extra area has been added? That's why it's not exact like that. Then like this. Then like this. Now you see we are losing area. We lost some area. We gain more area. And once I get here, so I use these lines. Can you see there? These heights have been used. If you notice, I didn't put a purple line on this last one because that was not used. Why was it not used? Because it is not this number over here, B, is not a left end point of any strip. So if you are going to use the left end points, you will create your heights. That's the main thing. The width of the rectangle is same is delta x for each of them. We already know what it is. The main thing is now how to find the height of the rectangle. Okay. So as I just showed you, what we could do is there are usually commonly three ways we pick the height. We can use the left hand points of the intervals, or we could use the right hand points of the intervals, or we could use the midpoint. Now, could we do pick any point? Yes, we could do that as well, but that's more haphazard. Until someone, for some reason, special reason, someone gave us that the first interval, first sub-interval, pick such a such point, and so on. But if it's not given, we use either the left or the right or the mid points. Okay. So now, for our in order to find this height, the first rectangle, I have to do what? I have to get the value, this value. And how can I get that? Well, this height is coming from here. It is we drew this vertical line at x is equal to a, which is also, by the way, is denoted by x sub 0. So what we have to do is find the value of the function at x sub 0 or at a. That will be the height of the first rectangle. So just to be consistent with the other these tick marks, we take a to be x naught and b is taken as xn. So now I can write the I can write my area of each rectangle if I know what these tick marks are. What are these values of these tick marks? And then we can go from there. So here, in order to do that, I need to know what are these tick marks. Yeah? And here is the formula. We denote x, the first endpoint of the interval, the starting endpoint of the interval AB. We call it x sub 0 or x naught. This is a marine word used in marine navigation. Naught is, I think, a unit of something. Anyhow, so this is a is x naught. How much is this one? This is delta x. Each one of these is delta x. Everybody knows that. So in order to get from a to x1, what do I have to do? What will be x1? Well, x1, remember, is the distance from here. But how do we know what that is? Well, it will be a plus delta x. So x1 is a plus delta x. What is x2? Well, again, it is delta x away from here. So it is delta x. So x2 is equal to x1 plus delta x. So you take the one, if you are finding in general, if you want to find xk, go to the previous one, which is xk minus 1, and add delta x in there. That gives you the next one. But this formula is okay, but this one is more simple. And how can we get it? Well, this said x2 is x1 plus delta x. But what is x1? x1 is a plus delta x. So we have another delta x. So we get a plus 2 delta x. Similarly, x3 will be x2. So up till here, we know this value, then we add delta x to it. So x2 plus delta x. But what is x2? Well, x2 was a plus 2 delta x. And then we have plus x. So we get a plus 3x. And so on. Okay? 3 delta x. So that's how we get these values. Now when we use the right endpoints, so then let me show you here. Yeah, over here. On this picture, I'll show you. So in the previous diagram, I had used the left endpoints, but I want to use the right endpoints now to create the rectangles. How will that look? So for the right endpoints, let me take a different color. For the right endpoint, so the first rectangle, the right endpoint is this. So which means this will be the height of my first rectangle. So this time I will go this way to complete the rectangle. So it will be this. So can you see we lost some area here? Okay, second will be right endpoint is this one, x2. So the height will be f of x2 and so on. That gives us a heights. So for corresponding to each of these x naught, x1, x2, x3 up to xn, we have a y value corresponding to each of these. So this will be f of y will be f of x naught. For this it will be f of x1, f of x2, and so on. So in this case, my first rectangle has a height f of x1. Whereas in this one, my first value was f of x sub 0. Okay. Now, okay, so if we are using the right endpoints, it means we will be using these ones, x1, x2, x3 up to xn, which is the b. So from x1 up to xn, how many rectangles those will be? N rectangles. Okay, but we have one extra tick mark because of the endpoints on both sides. So if we use the right endpoints, then we will be using what heights will we be using? The height first rectangle is f of x1, second will be f of x2, third height will be f of x3, and so on. The last rectangle will have its height f of x sub n. So we say the height of the ith rectangle is. So what will be the height of the ith rectangle? Well, if you note here, the height of first rectangle is x1, second is x2, f of x2, third is f of x3. So what does that tell you? So the height of the ith rectangle will be f of x sub I. What will be the width of that rectangle? Yes, delta x. Remember, the width of each rectangle is delta x. So now what will be the area? Remember, the area of a rectangle is base times height, or base width times height, or base times length, whatever. So here we will say the area of the ith rectangle is f of xi times delta x. So now it means the sum of all the areas will be f of x1 delta x plus f of x2 delta x plus dot 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 plus f of xn delta x. And now I can even factor out the delta x, and I'm left with f of x1 plus f of x2 plus dot 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 plus f of xn brackets delta x. This is going to be the sum of the areas of the rectangles. Well, we use the right endpoint, remember? So this is the kind of a name that we give to the sum. R sub n. R is for the right, n is for the number of terms we have here, or number of rectangles we have created. And this is called, well, I will come back to what this is called, but let's look at left endpoints. Now, if we were to use the left endpoints, then we will be using the x sub 0, x sub 1, x sub 2, x sub 3, and so on. And then we cannot go up to x sub n, because it will be more than the rectangles we need, or more than the terms we need. And also because the x sub n is not a left point of any interval, sub-interval. So this is only the right endpoint, and this is only the left endpoint, but the in between are both left and right endpoints. So we will start at x sub 0 and we go up to x sub n minus 1. Okay, so here the sums will be f of x sub 0 delta x plus f of x sub 1 delta x plus da 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 plus f of x sub n minus 1 delta x. Or the same way as we did before, factor out the delta x Okay, so now comes that summation notation. So see, can you see, I can write this as summation f of, so what is changing? X is not changing, the index is changing, the index of the x. So we can write it x sub k, k is going from 1 to n. So we can, and wait a minute, we are forgetting delta x, delta x. Now can I move the delta x out here? We don't see an k in here, but remember, do not move it out yet. When we do the calculations, if we need, we can move it out. First, we have to know exactly what is delta x. And in this case, it will be summation k is equal to 0 to n minus 1 f of xk delta x. So this quantity is the same, so only the index is different. So the summation notation comes into play in here. Now these quantities, the R sub n and L sub n, these are called right approximation sum and the left approximation sum. So Rn is the right approximation sum, Ln is the left approximation sum. They have another name. They are also called right Riemann sums and left Riemann sums. So Riemann was a mathematician. He was a student of the very famous mathematician Carl Friedrich Gauss. Okay, so now that we have this idea of creating rectangles and then figuring out how many and adding the area and estimating the area under the curve, we note that as we increase the number of rectangles, the wastage of the area gets smaller and smaller, or you can say the error between the actual area and the calculated area becomes smaller and smaller. So we can say and can now use the concept of limit. Okay, so if we have n is huge and it's going to infinity, then what will happen? There will be more number of rectangles. What does that do? That reduces the width of the rectangle. Height will remain the same. Heights will remain the same, but the width of the rectangles will become smaller. So as n goes to infinity, delta x approaches 0. And we say that the R sub n, the right Riemann sum, approaches the actual area. So in this case, it is not the actual area. This is not the actual area. This is not the exact area. Similarly, this sum is not exact area, but when we apply the limit, we let n go to infinity, then that is whatever we get, it will be the area. Okay, I will stop the video here because it has already become very long. So I'll talk about rest of the stuff in the next video.